Hey, so today now we're doing factors, multiples, prime numbers, and composite numbers. So this is a division, right? Right. So what are factors? Factors are numbers which can be divided into that number without a remainder. So factors are generally not bigger than the number you are looking for the factor of. For example, right? We're looking for factors of 16, right? What numbers can be divided into 16 without a remainder? Right? 1, right? 2, right? 4, right? 8, and 16, right? Generally, so factors generally it won't exceed the number that you are looking for the factor of, right? So, but if I had 24, right? I know 1 times 24. This is what one you did. 1 times 24, right? 2 times what is 24? 2 times 12. Can 3 divide into 24? I don't think so. How's 4? Yep. 4 and 6. How's 5? No. And then 6. Right? So 1, 2, 4, 6, 12, 24. Right? Those are factors. So factors are numbers that will always be below the number that you are looking for the factor of. Right? Now, what are multiples? Multiples of a number are numbers that can be divided into without leaving a remainder. Right? So these numbers can divide into here without leaving a remainder. With multiples, it's the opposite, right? So if I ask you for the multiples of 3, right? 3 can divide into 3. 3 can divide into 6. 3 can divide into 9, right? And it goes on, right? There are many multiples, right? So basically what you're doing here is just saying 3 times 1, 3 times 2, 3 times 3. Those are multiples, right? For example, if you have 5, right? What's 5 times 1? 5. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. And it goes on, right? You can go up to like 5 times 30, 40, whatever. It goes up to infinity. Generally, multiples are infinite. They are many. They don't end. They can go on forever, right? Regardless of a number. Whereas factors are limited. Factors, they aren't many. They're limited, right? Are we together? Now, what are prime numbers? A prime number is a natural number. Do you remember natural numbers? It's numbers greater than 1, right? And which only have 2 factors, which is 1 and itself. For example, if you had a number 11, right? What are the factors of 11? It's 1 and itself. 11, right? Think of the number 7. It's 1 and 7. There's no other numbers that fit into it doesn't have like many factors. It's just one in itself. It's a prime number, right? Now, what are composite numbers? Composite numbers are the opposite of prime numbers, right? They are numbers that are greater than 1 and are not prime. So these 16, right, has 1, 2, 4, 8, 16. Like these don't have two factors. These have more than two factors, right? More than two factors. So a number that has more than two factors, right, is a composite number, basically. Got it? Any number that has more than two factors is a composite number. Are we together? Great. Let's do a few examples. Right? We're going to list the factors of 30. Right? What are the factors of 30? This is generally the notation that is used, the way it's written. Right? Like 30, two dots, and then we have these curly brackets. You could also have like a equal sign here. Right? So, the factor of 30 is y times 30, right? It's 2 times what? 2 times 15, right? 3 times 10. And 5 times 6. I'm sorry that it's so, right? So these are the factors with 1, 2, 3, 5, 6, 10, 15, and 30, right? The way I like to do it to find factors is, I don't know if you got it, is what two numbers multiply each other to get 30. So 1 and 30, 2 and 15, 3 and 10, right? And 5 and 6. So I do it, right? You could list them one by one, that's fine, right? But this is how I do it, right? Now, let's look at the prime factors of 30. Now, you might be asking yourself, what is a prime factor, right? A prime factor is do you remember prime numbers? Right? It's numbers that have two factors, right? So, from this list above, right, which of these factors are prime numbers? Right? Prime numbers are greater than 1. So it's not 1, right? So I'm going to have 2, right? I'm going to have 3. I'm going to have 5. 6 has more than 2 factors. 10 has more. 15 has more. And 30 has more, right? So this 2, 3, and 5. Okay. Now we can list the even factors of 30. Right? What are even factors? From the factors above, which of these factors are even numbers? Right? Is 1 an even number? No. Is 2 an even number? Yes. 3? No. 5? No. 6? Yes. 10? Yes. 15? No. And 30? Yes. See how it works? Right? It's not that difficult. Yeah. And what we can do now, let's say we're looking for composite factors. Right? What are composite factors? It's factors that are not prime, right? And are greater than 1, right? So 1 is not can't be a composite number because it's 1, right? Remember, composite numbers and prime numbers are always greater than 1, right? Is 2 a composite number? No, it's a prime number. Is 3 composite? No, it's prime. Is 5 composite? No, it's prime. Is 6 composite? Yes. 10? Yes. 15? Yes. Right? I'm 30. Yes. Are we together? Great. The lesson we're looking at is writing a number as a product of prime factors. Right? All composite numbers, right, can be written as a product of their prime factors. This means like a prime number times a prime number times a prime number, right? All composite numbers can be written as such. For example, 12 is a composite number, right? And 12 can be written as 2 times 2, which is 4, times 3, which is 12, right? And these are all prime numbers. This is all written as 2 squared times 3, right? For those who don't know how we use square numbers, it's how many of this number exists. 2. Therefore, it's 2 there, right? We could add a 1 here for 1, but it's not needed, right? Generally, if it's 1, you don't add the 1, you don't write the 1, but it's there, it exists, right? Now, if it's a more complicated number, right, generally we use something called the ladder method, right? The ladder method. So what is the ladder method? It's a method that you use to, at the end, get a product of prime numbers for that number, right? There's 3 steps, right? Step 1 is you divide the number by the smallest prime factor. The smallest prime factor. Second step is you divide the new answer by the smallest prime factor, right? Step 3. You repeat the process until the answer you get is 1. Right? Let's work through it. Right? Let's write write 24 as a product of its prime factors. Right? So this is how the ladder method works. Right? You draw a line. Right? And you write 24 on the right hand side on top. 24 being this number here, right? Now, you are divide this by the smallest prime factor, right? What are the potential prime factors we have? We have, for example, 2, 3, 5, 7, 11, and it goes on, right? These are all prime numbers, right? Now, can 24 divide by 2? Yes. So you write 2 here. So what is 24 divided by 2? 12. right? And you're going to repeat this process until you get the answer of 1, right? Can 12 divide by 2? Yes, it can. 2. What's the answer? What's divided by 2? 6. Yes. Can 6 divided by 2? Yes. The answer? 3. Right? Can 3 divided by 2? No. Can 3 divided by 3? Yes. What's 3 divided by 3? 1. So we have gotten the answer of 1. Can you see it? Got it? It's called the ladder method because this looks like a ladder. See? Great. So now that we've gotten this far, right? All we do is we multiply the numbers that are here. Always write them out, right? And this is the product of its 5 factors, right? Look. It's simply 24 is equal to 2 times 3 times 2 times 3. This came from here. 2 times 2 times 2 times 3. Right? Remember what we did here? So we can simplify this, right? 2. How many 2's are there? 1, 2, 3. Times 3. How many 3 are there? Just 1. So we can leave it out. Right, and that's your answer. See? Let's do it again. Or another example. We're going to write 60 as the product of its prime numbers, right? Right? Remember? 60, right? The number of your prime numbers. 2, 3, 5, 7, 11, and goes on and on, right? Now, let's start with the smallest one. Remember? Smallest. Can 60 divide by 2? Yes. What's the answer? 60 divided by 2 is 30. Can 30 divide by 2? Yes. What's the divided by 2? 15. Can 15 divide by 2? No. Can 15 divide by 3? Yes. What's 15 divided by 3? 5. Can 5 divide by 2? No. Can 5 divide by 3? No. Can 5 divide by 5? Yes. Alright? What's 5 divided by 5? 1. Alright? Right? So it means 60 is equal to, right? 60 is equal to what? 2 times 2 times 3 times 5. If we simplify it, how many 2's do we have? 2. How many 3's do we have? Just 1. And how many 5's do we have? Just 1. And that's your answer. Right? And you can do this for as big of a number as you can. Right? You can go on with this. Right? Let's try a number 2,700. Right, so we're going to write 2,700 as the product of its prime factors. Right? 2,700. Right? Now, can 2,700 divide by 2? Yes, it can. Every even number can divide by 2. So you know, right? So the answer 2,100 divided by 2 is 1,315. Right? Can this divide by 2? It's even, so yes. What's 1,350 divided by 2? 675. Right? Now that this is not even, so it cannot be divided by 2, right? So let's try 3. Can this divide by 3? Can 675 be divided by 3? Yes. Right? What's 675 divided by 3? 225. All right. Okay, let's do by 3. Yes. What's the answer? 75. If I'm going too fast, you can do this on a calculator, or you can do it on a similar piece of paper. If I'm going too fast, you can do this on a separate piece of paper. You can pause the video, or you can do it on a calculator. And the best way you learn is by doing the problems with me. Okay. So can 75 divide by 3? Yes, it can. Right? What's divided by 3? 25. Can 25 divide by 3? No, it's not. Can you divide by 5? Yep, can. Right? What's divided by 5? What is 25 divided by 5? 5. Right? And then 5 divided by 5 give you 1. Right? Yeah, the letter. Right? Then all we do is 2,700 is equal to 2 times 2 times 3 times 3 times 3 times 5 times 5. Right? And then we simplify this. Right? 2. How much do we have? 2. Times 3. How much do you have? 1, 2, 3. Times 5. How much do you have? 2. That's your answer. Right? Hope you understand.